So today the last class in the for the unit 3, that is polynomial representation of linked list or arrays. Polynomial representation using linked list and arrays. Okay, you can see here. So how I represent a polynomial using a linked list and how I will do the operations of addition and multiplication on the on this polynomials. Okay, 1 minute. I will see. So you can see the polynomial 1 minute. Okay. Is it audible now? Is it visible and audible? Can anybody reply? Okay. So now the last topic in the unit 3 is polynomial representation using linked list and arrays also. Anything is okay. How I will represent a polynomial? So you can see here. So how I represent a polynomial? You can see the thing. See, a is equal to, for example, that there is a polynomial x 3x to the power of 14 plus 2x to the power of 8 plus 1. So how I will write that one? See, first part in the node, that is linked list node, is 3. Next is 14. Next is address of the next node. So here you can see 3 is that is coefficient is kept in first part of the node. Next exponent part 14, x to the power of 14. This is kept in second node, second part of the node. Next one is, all of us know, that is the address of the next node. In the next node, what I will keep? The next term in the what we call the polynomial. These are polynomials. This is the whole is a polynomial, and each one is a term. There is 3x power 14 is a term. So this I will represent in one node. 2 into x power 8 I will represent in one node. 1 I will represent in one node. So you can see here. Again 2, 8, 1, 0, null. So you can see here 2 into x to the power of 8. So 2 I kept in first part of the node and 8 in second part of the node. And the third part of the node is nothing but the address of the next node. Again, you can see plus 1. 1 means what? 1 into x power 0, x power 0. Coefficient is there, only coefficient is there, no x is there, means what? X power 0 is there. So 1 is kept in first part of the node. Next 0 is kept in second part of the node. Because this is the last term in the linked list, I will keep as null. So there is no further term in the polynomial. So null I will keep in the last node of the polynomial representation. So you can see. In the same way, here also b is equal to 8 into x power 14. So 8 I kept in first part, 14 I kept in second part. Third part is the address of the next node. Again minus 3 x power 10. So minus 3 I kept in first part, 10 in second part, and last one is, and third part is linked to the next node. And again 10 into x power 6, 10, 6, null. 10 is the first part of the term, 6 is the exponent of the x, and null is the address of the next node, because the 10 into x power 6 is the last term in the polynomial. There are no further what we call terms in the polynomial, so there will be no further nodes also in the representation of the polynomial. So I will keep null, null. So that I think most of you have understood. So in one word I can write like write the node of each each node in the linked list. First part is coef, coef, coefficient. Next one is exponent, expon. Next one is link, link. Okay. So the same thing I represented in our data structure node. Okay, you can see here int coefficient, int exponent, poly underscore pointer link. So poly underscore pointer link means what? It is nothing but poly underscore pointer is nothing but a pointer to the array, a pointer to the node of type poly underscore node. Okay. Now to add two numbers. So mainly what you have to understand is this part. What you got? COEF expon, expon. Next one is link. Okay. 1 minute. So that thing you have to understand. So now you can see here. So to add two polynomials, we examine their terms starting at the node pointed at 2 by a and b. So just we will see the algorithm. So if the exponents of the two terms are equal, then means what? Add the two coefficients, create a new node to a term for the result. So I told in the entire polynomial, each part is named as term. So that's what he is telling. Add two coefficients, create a new term for the result. If the exponent of current term in A is less than B, create a duplicate term of B. Attach this sum to the result called D. Advance the pointer to the next term in B. We take a similar action on A if A of exponent is greater than B of exponent. See, how can, if there are two terms in a polynomial, how can I add? For example, you can see here 3 into x power 4, and in B 8 into x power 4 is there. Since exponent is same, I can add these two terms. But if you see here 2 into x power 8 minus 3 into x power 10, if two things are there, but here exponent 8 is different, exponent 10, here exponent 10 is different, so I can't add these two terms. So in the result I have to keep separately this 2 into x power 8, I have to keep it separately. 3 into x power 10 I have to keep separate. Okay. In the same way, 10 into x power 6, here 1 is there, 1 into x power 0. These two exponents are different. Only I can add the coefficients of two terms if the exponents are same. If the exponents are not same, I can't add the things. Okay. So that's what he is telling. That's what he wants to do. Now you can see the diagram here. By seeing the diagram, you have to understand. So you can see 3 into x power 14, 2 into x power 8, 1 into x power 0. Next, 8 into x power 14 minus 3 into x power 10, 10 into x power 6 null. So you can see here. So first I will compare these two. See, pointer A is pointing to this node and pointer B is pointing to the first node in this linked list. Now I will compare. So if I compare these two, you can see. See, both 14 and 14 are equal. This exponent part is equal. So then what I will do, I will add 3 plus 8. So I will get 11. And 14 is same. Next one is null. So because this is the first node in the resultant linked list, I will keep the next node address as null. So next you can see. Next part you can see. So I will advance to the second terms in the two linked list, 8 and 10. So you can see here. 8 and 10 here. So you can see. Now see, 10 is greater than 8. This both exponents are not the same. 8, 10, both are not same. So what I will do, I will take the maximum one, that is 10. And I will just copy this second term, minus 3, 10, to the resultant. Okay, you can see here. Okay. Next, you can see here. Next, the B is advanced to the next node. Now, what I will do, again compare this second term in the first linked list with the third term in the second linked list. So what I will do next, see, because here you can see a of exponent is greater than b of exponent. Previously, a of exponent is less than b of exponent. A of exponent is 8, b of exponent is 10. Since a of exponent is less than b of exponent, what I have do, I have copied the a of exponent. Now you can see a of exponent is greater than b of exponent. So I will copy the less one. So which is less one here? Minus 3, 10 was the less one. So what I will do, 1 minute. Previously I copied minus 3, 10. Now you can see here 2 into 8, 8 and 6. You have to compare 8 and 6. Which is less? Which is greater? 8 is greater. So I will copy the term with exponent 8 in the linked list, in the third part of the linked list. So you can see here. Okay, 1 minute. I think most of you understood. One simple thing, I have to write the polynomial in the descending order of the exponents. That's the thing. That's the main thing you have to understand. So the same thing that was over, that was done here. So you can see here. So in the same way, I will do the whole job. So you can see here. In the same way, I will be going on adding the terms. So you can see the thing also here, what you call the program also you can see here. And So you can see the simple algorithm here. First, poly pointer P add point poly pointer A, poly pointer B. So these are nothing but you can see here. Poly pointer A is the pointer which represents the first node in the first linked list represented by the first polynomial. And B also here, first node represents the first node in the second polynomial represented in the second linked list. You can see. So you can see here, poly pointer front rear 10. A and B are pointers to two polynomials which should be added. So you can see here, rear is equal to poly pointer malloc. If A is equal to rear, F front, F front, F front, while A and B switch. So you can see. So here three cases you can see. A of exponent is less than B of exponent. A of exponent is equal to B of exponent. A of exponent is greater than B of exponent. Three cases. So in three cases, what we have to do? It was written. So what if A of exponent is greater than is less than B of exponent, then what I will do? I will add B of coefficient and B of exponent to the rear part of the Q. So what he has what he has done? He is representing the whole thing as Q. So where I will add in the Q by using the rear part in the Q. So each node I will add to the rear part in the Q. So you can see here, while A and B switch compare A to the A exponent, B exponent. Now you can see case -1. A of If A of exponent is less than B of exponent, obviously B of exponent is greater. So I will add the B of exponent part, that is term represented by B, that is term represented in the linked list, second linked list, to the final linked list. How I will do? I will do by using attach B of coefficient, B of exponent, and whichever is greater than that I will add to the final resultant linked list or resultant Q linked list. Okay, that's what he has done. Next, B is equal to B of link break. If A of exponent is equal to B of exponent, then what I will do? I will sum A and B coefficient. A coefficient and B coefficient I will add. If sum, attach sum A of coefficient, sum A of exponent and rear. So you can see here, sum is equal to A plus B. That is A of coefficient and B of coefficient. That part and exponent same part, and rear I will have attached to the rear part. So next one is A is equal to A of link. Next B is equal to B of link. Here both parts I have to what we call them, forward the link of pointer A and pointer B. But here in case one, just I am copying only one thing, that is B component, that is pointer B. So I am not copying A to the resultant. So you can see here, I am not copying A in case -1. A of exponent I am not copying, only I am copying B of exponent. So what I will do? I will copy B of exponent only. So that's why I will have to move to the next node. How I will write? B is equal to B of link. So in the same way, sum is equal to A of coefficient plus B of coefficient. If sum attach is equal to sum of A of coefficient, sum and A of exponent comma rear. So that's the case. Why he has written if sum? Because in some cases it may become 0. Then there is no need to attach anything. If for example, in coefficient, 1 minute, if in A coefficient, if we take as exponent 14 and 14, first point, if we take, for example, 3 is there. In the next coefficient part, -3 is there. Then what will happen? 3 plus -3, it will become 0. So that's what here you can see. If sum, attach sum A of exponent and ref. Next, A of link B of B is equal to B of. So you can see here. So whenever the exponents are same, 14 and 14, what I will do, I will add the two coefficients 3 and 8 to the 11, and I will go to the next node in the two linked list. I will go to the next. See, A is incremented to the next node, B is incremented to the next node. Whereas if A of exponent is less than B of exponent, or A of exponent is greater than B of exponent, anything greater or less than, in these two things only one part of the linked list will be moved to the next node. For example, if we see the example here 8 and 10, because 10 is greater than 8, I have to add this part to the second node 10. So obviously I will increment the B value. Since B is copied to the resultant linked list, I will increment the B pointer. Here in the third part, if you see, I am copying 8. I am copying 8 to the 8 node to the linked list. So what I will do, I will obviously next move the link A to the next node. So that's the thing. That's why you can see here in these two parts, -1 and 1, when A of exponent is less than B of exponent, or A of exponent is greater than B of exponent. In these both things, only one will be forwarded. Only one pointer will be forwarded. B is equal to B of link, or A is equal to A of link. Whichever I am copying, that will be what will be forwarded. Okay. So that's it. So next, copy rest of list and A and then list B. So here see, for A is A of link, attach A of coefficient and B of A of coefficient and A of log. See, after doing all these things, after trying to compare, in this switch case, what I'm doing, I'm comparing the exponents. I am comparing the exponents. After comparison of all exponents, what I will do, if in link A some are left, in link B some are left, I will add to the final result. That's what he is telling. He is doing. Copy rest of list of A and then B to the linked list. So you can see here. For example, you can see here. See, 8 and 6 are compared. Next one is 8 is copied. Next, 0 and 6 will be compared and 6 will be copied. Next, 0 is left in the linked list because there is no need to compare anything in the other linked list. All are copied. See, first, this 14 and 14 were added. Next, 8 and 10 were compared and 10 was added. Next, 8 was added. Next, 6 plus 6. See, 8 and 10 were compared and 10 was copied. Next, 8 and 6 were compared and 8 was added. Next, 0 and 6 were compared, and next what will be happening? 6 will be added. But 0 is left in the linked list. So all these left nodes will be added to the final result of the linked list. That's what he is telling in this part. Copy rest of list of A and then list of B. So here, delete extra initial node. So you can see here. If there are extra initial nodes, I will delete that one. Okay. So you can see. So you can see the algorithm for attach. Previously, I have written here attach. So you can see here what the function I have used, attach here. Attach. You can see this function. So now we will discuss the attach function. So you can see here. So what this meant for? What this attach function is meant for? Create a new node with coefficient is coefficient and exponent is exponent. Attach it to the new node 2 by pointer. Pointer is updated to point to the new node. So you can see here. So poly pointer temp is equal to poly pointer malloc. So one pointer is created. For each node, I have to create a pointer. That is if a node is created means what? New in the resultant one, you can see here. This C you can see. This third part is nothing but a resultant linked list. Third part is nothing but a resultant linked list. Third part is nothing but a resultant linked list. So you can see temp is equal to poly pointer analog size of polynode. So analog size of polynode. So you can see that. If E is full of temp, printf the memory is full. లేకపోతే నెక్స్ట్ ఏం చేయాలి? Temp of coefficient is equal to temp of exponent star ptr of flux is equal to temp and ptr is equal to temp. Okay, so that is the thing. This is nothing but these 4 lines are nothing but adding the new node to the existing list. This part is equal temp is equal polynode analog means creating a new node. Okay. So you can see the analysis of polynomial addition. Okay, see. So you can see coefficient additions, exponent comparisons, 3 parts. Coefficient additions, exponent comparisons, creating of a new node. So you can see. So you can see. Next thing we will see. So by using array, the same thing I can do by using an array. If I'm using array, how I will represent? You can see. See, this is representation. 1 minute. See, this is representation by using linked list. The same thing if I want to represent by using a array, how I will represent this one. So you can see struct poly float coefficient int x. Okay, so you can see. So you can see here. So you can see. So here, one minute. So here int I, int degree 1, int degree 2, int k is equal to 0, I is equal to 0, n is equal to 0. Printf highest degree of 1. So another thing what you have to do is see, A of 50, B of 50, C of 50, D of 50. These are nothing but the representations of each polynomial. How I will represent that one? By using the struct poly. So that's the thing. 1 minute. So you can see. So enter the highest degree of the polynomial. Is it x power 14 or x power 15 or x power 19? So next one. So for I is equal to 0, I less than degree, I less I plus plus. Enter values in the coefficient of the polynomial. So printf enter the coefficient of x, that is I. So I have written. So you can see scanf percentage of a of I dot coefficient. Enter the values in exponent of the polynomial term. So exponent, what is the exponent? For example, 3 into x power 14. So 3 into x power 14 means what? 3 is represented in a of I dot coefficient in x power 14. X power 14, that exp part 14 will be stored. That's it. So you can see the things. So in the same way, what I am doing, I am reading the second polynomial also. Printf enter the highest degree in the polynomial. So printf highest degree in the polynomial. So for I is equal to 0, I less than degree 2, I plus plus printf enter the coefficient of x. That is I. That will be copied in coefficient of b of I dot coefficient. Okay, b of I, that is enter the coefficient. So b of I dot coefficient. So you can see here b of I dot coef. Next, b of L plus plus dot exp is equal to I. So that is the exponent. Starting, for example, x power 14, x power 13, x power 12, like that we will come. So each one I will be copying in exponent part and each one I am copying in coefficient part. So you can see. So now how I will be adding the two polynomials, you can see here. You can see. So you can see if degree of 1 is greater than degree of 2, for I is equal to 0, I less than of degree 2, I plus plus. Cm of coefficient is equal to A of coefficient plus B of coefficient up to Cm of coefficient. You can see that one. One minute. So you can see. So what I am doing, I am adding the two coefficients and I will, since the exponents are same, what I am assuming is both will have the same exponents and both will have the same number of terms. That's what I am. My assumption is in this array representation in this program, particular program. What I'm assuming is, so you can see in the example. For example, you can see here. So you can see x power 0 coefficient is 2, x power 1 coefficient is 3, x power 2 is 5, x power 3 is 1. At the same way, in the second one is x power for 0, x power 0, 7, x power 1, 8, x power 2, 5, x power 3, there is nothing. So what I am assuming here is I am just from the highest value of the exponent, I am just decrementing one by one value of the exponent, but both are, but there is no gap. If I am having the x power 3 highest term in the what we call in the polynomial, then what my assumption is, next term is x power 2, next term is x power 1, next term is x power 6. Nothing like in the previous example of a linked list representation, what we have seen is x power 14 and x power 8 next term is not like that. You know, present example, what I'm assuming is highest, if I say the highest exponent is x power 14, then automatically 13 new terms will be in the polynomial. That is x power 13 will be there, x power 12 will be there, x power 11 will be there, like that. So that is my assumption. So you can see here. So if that is the assumption, what I will do? So obviously, and each term for I is equal to 0, I less than degree, I less than I plus plus, CM of coefficient is equal to coefficient 1 plus coefficient 2. Exponent is also the same exponent, m plus plus. So you can see here. You can see here. So what I will do? For example, if the degree of 1 is greater than degree of 2, that is, degree of 1 is for some x power 10, degree of 2 is x power 5. So what I will do? So obviously, first I will add for I is equal to 0, I less than degree 2, until degree 2 exponents I will add. Now, since degree 1 is highest, what I will do? The rest in the degree 1, I will add to the remaining polynomial. You can see. Next. In the same way, if degree 1 is less than degree 2, so what I will do? Degree 1 is less than degree 2. What will happen? You can see all the degree 1 will be added, exponents will be added. The exponents that are in degree 1 will be added first. And next to for loop, what will be there? The rest elements in the polynomial will be added. So that's the thing. So you can see the example here. So coefficient, first one is 3. Highest degree is 3. So you can see here. So coefficient of 0 is 2, coefficient of 1 is 3, coefficient of 2 is 5, coefficient of 3 is 1. So x power 3 plus 5. So how I will represent, 1 minute, how I will represent this one? 1 into x power 3, x power 3 plus 1 minute. 1 into x power 3 plus 5 into x component plus x component 1 plus what? Is it visible? The next one is 1 into x component 0. So that's it. So next one is next polynomial is highest component is 2, highest exponent is 2. So how I will represent? See, 5 into 5 exponent 5 into x power 2, 1 x power 2 plus 8 into x power 1 plus 7 into x power 0. So these are the two polynomials that were here. So now what I will add? See, 1 into x power 3. Here 1 into x power 3, that exponent 3 part is not there. So I will not take this one. So how I will do now? I will start from the second term in the first polynomial. 5x power 2. Here also 5x power 2. I will both add that one. And next 3x power 1, 8x power 1. I will add these two. 1x power 0, 7x power 0. So these are the things I will add. So you can see. So you can see here. 2 into 0 plus 3 into x power 1 plus 5 into x power 2 plus 1 into x power 3. So you can see that 1 into x power 3 plus 2 into x power 2 plus 3 into x power 1 plus 2 I think. Okay. So now the second one is, you can see 7 dot plus 8 into x power 1 plus 5 into x power 2. So you can do the same thing. You can see here. Okay. In the reverse part he is written. So if I add these two, so what will happen? So you can see here. See, 1 into x power 3. X power 3 is only 1 here. So that came at the last. Next, 5 into x power 2. 5 into x power 2. 10. 8 into x power 1. 11. 2 into x power 0. 7 into x power 0. 9. So that is the answer. So in this way, I will be getting that. So that is the value. This is array representation. Previously, I have talked about the linked list representation. Okay. So you can see the same thing using, you can do the multiplication also. You can do the multiplication also. So you can see here. So int coefficient, int power, int struct, link, star, next. So this is the if you understand this part mainly, you can understand everything. So struct poly 1, poly 2, poly. Poly means the just poly link means what is the result? It is the result linked list. So you can see the same thing. Poly add. If poly 1 is power of is greater than poly 2. If poly 1 is less than poly 2. If poly 1 is equal to poly 2. Else means the third case. If both are same, what I will be doing? Just I will be adding. So you can see poly 1 of coefficient is equal to poly 1 of coefficient 1 plus coefficient 2. So both I am adding. So this is also another representation of the polynomial. I think this is nothing but multiplication. This is multiplication. This program is related to multiplication. So line by line, if you decode, you can understand things. It is not so difficult. Yes, it's in poly multiplication. Okay. So today I will end this session. What you have to do is you have to practice. I will be sending today. I will be sending the whole unit 3 material to you. One by one. You have to practice on your own. Okay. This is not the EEE subject. It is a CSC subject. So you have to practice on your own. And another thing I have told, for attending the campus drives nowadays from last 3-4 years, coding paper is given more than 50% weightage. I can tell it is a 60% of your campus drive program exam will be in coding only. That coding is mainly in C and Python. So C and ES, so it will be useful for campus drive also, for your campus drives also. Okay. So let's try to crack that first. To crack that campus drive coding, first you have to practice this programs. That is, first you have to understand and practice the programs related to your exam. Okay. So today I will be ending the session. Thank you. Any more doubts? Anybody has having any doubts? Can okay. Why it's not opening? Zip file I think I have sent. Okay. Anyway, I will be sending anyway once more. I have sent your zip file. No zip file. If you don't know opening the zip file also. Oh yeah, it's a zip file. I think 1 minute. I will see. What I think it's a zip file. 1 minute. One minute. What I know is zip file. Yes, zip rar. That is rar means it's nothing but a one type of zip file. See, one type of zip file. It is nothing but. So you can do that one. There is no what we call. It's not so too difficult. I didn't kept in PDF because there are many different of programs. Some programs are there, some PPTs are there, like the different types of files are there. That's why I zipped that one and sent you. See, so these are the rare file, nothing but a zip file. You can open that one easily, just clicking on that, or right click. If you right click, you will get extract from rare file. So extract, if you click, automatically that will be extracted into a folder. So that's not a big deal. Okay. So I will be stopping this one. Okay. I think all of you can practice that one. Practice this. What we call units. Okay. Today or tomorrow I will send you the third unit also for you. That is also it will be in a zip file, because different Word files, different PPTs, different PDFs will be there. Okay. Okay. Stopping. I'm ending this session.